You have already learnt that when silk is rubbed on glass, the glass develops positive electric charge and the silk negative charge. These charges remain still on those bodies and are therefore called static electric charge. What will happen if these charges are made to move by applying force? A flow or current of charges will be created. When water flows down a slope, we call it a current of water. Similarly, a flow of electric charges is called an electric current. We now take a dry cell used in torch. Then take two copper wires and a bulb. This dry cell has two poles, positive and negative pole. One end of each of these wires is connected to cell and the other ends to an electric bulb. We observe that as soon as the wires are connected to the cell and bulb, the bulb starts glowing. Do you know why the bulb starts glowing? The cell has chemical energy stored in it. This energy pushes static negative charge to flow through copper wire towards the positive charge. Thus, electric current is generated. This current passes through the filament, that is, the fine wire of the bulb, and makes it glow by raising its temperature. Let us now understand the functions of the electrochemical cell.
Functions of the electrochemical cell. We take a narrow plastic tube ABC and hold it vertical as shown. Now we take some marbles and drop them one by one into the tube from the end A. We observe that marbles roll down the tube. We can collect these marbles from end C. Now marbles cannot climb the slope from C to A, but if you pick up the marbles from C and take them at A and drop it, it will start to roll down through the tube. This is exactly what the electric cell does. Now we collect these marbles and drop them at A again. This is how current goes on flowing through the circuit. The force applied by an electrochemical cell is known as electromotive force, that is, the force that sets electric charge in motion. We know that current flows due to the force applied by the cell. Let us now study the different types of cells. We will first study the simple cell.
Simple cell. We first take a glass trough and then pour dilute sulfuric acid in the trough. Now we take a zinc plate acting as negative plate and copper plate acting as positive plate and insert them in the dilute sulfuric acid. Then we get a bulb and a key or a switch. This bulb is used to indicate the flow of current. That is, when current flows through the bulb, it starts glowing, as we have seen earlier. Key is used to control the flow of current by closing or opening the key as and when desired. The key is closed to allow the current to flow and is kept open to stop the flow of current. Now we connect one end of wire to zinc plate and other to the bulb. Using another wire, we then connect bulb and key and then one more wire from key to copper plate. Initially, the key is kept open. Then we close the key for the current to flow. As soon as the key is closed, the current starts flowing and the bulb starts glowing. Electrons move from the positive pole, copper, towards the negative pole, zinc. Thus, electric current is generated due to the chemical reaction taking place in the cell, and it flows from positive pole to negative pole. This cell is known as voltage cell or voltaic cell. Leclanche cell. I hope you all understood the voltaic cell well. Let us now move on to the next cell, which is called as Leclanche cell. The cell was made in 1866 by a French scientist, Georges Leclanché. Leclanché cell consists of an outer glass vessel which is filled with ammonium chloride solution. This vessel contains a zinc rod acting as negative pole and a porous container containing mixture of powdered manganese dioxide and carbon which acts as positive pole. The current starts flowing due to the chemical reaction taking place between manganese dioxide and ammonium chloride. This was Leclanché cell. I hope you all have an idea of how Leclanché cell works and the chemicals used in the cell. Let us now move on to the next cell, the dry cell, that is so commonly used today. It is a modification of the Leclanché cell. Dry cell. The dry cell is a modification of wet Leclanché cell in which ammonium chloride solution is replaced with a jelly or moist paste of ammonium chloride and zinc chloride. Dry cell's outer covering is whitish, which is made up of zinc, and it acts as negative pole. Now, break open this covering. You will see a carbon rod. This is positive pole. Around this rod, there is a mixture of powdered manganese dioxide and graphite held in a bag of thin material. The space between this bag and outer cylindrical zinc cover is filled with a moist paste of zinc chloride and ammonium chloride. Then, carbon rod is fitted with a metal cap and the cell is sealed. The outer zinc covering is surrounded by an insulating thick covering to prevent anyone from getting a shock when touched. Let us now see where the cell is used and what its advantages are. It is used in general purpose and low-cost applications like in electronic toys, radios, torches, etc. Let us now see its advantage. The chemical reaction taking place in such cells is very slow. Hence, the reaction goes on for a longer period. Thus, the dry cell has longer life than other cells. Nickel-cadmium cell. Let us now study nickel-cadmium cell. In this cell, the metal cadmium, Cd, forms the negative pole and nickel, Ni, the positive pole. The space between the poles is filled with the alkali potassium hydroxide. The cell is made airtight to prevent both leakage and corrosion. It is rechargeable and can be used again and again. Hence, it is used in portable machines, garden tools, digital cameras, etc. Now we move on to the last cell, which is button cell. Button cell. As the name suggests, this cell is button-shaped. It is used in wristwatches, pocket calculators, toys, etc. The small size cells are used because of the limits of space in these devices. This cell is also known as lithium cell. It has negative pole of lithium iron phosphate and a positive pole of carbon. The space between the two poles is filled with a lithium salt. Advantages of lithium cells. 1. Lithium cells are easy to use. 2. This cell does not leak. 3. It does not cause damage to other delicate parts of the gadget. Let us see its drawback. 1. The lithium cell cannot be recharged. It simply needs to be replaced with a new cell. Hence, when our watches stop working, we need to replace the cell so that it starts working again. Next, we will study the magnetic effect of electric current. The magnetic field of current is called electromagnetic field. It means electricity produces magnetism. This concept can be understood from the following experiment. We take an empty matchbox tray and place a magnetic needle in it. Now, we wind 3 or 4 turns of copper wire around the tray. We connect the 2 ends of the wire to the pole of a dry electric cell and then insert a key in the circuit. Initially, key is kept open. We see the magnetic needle is resting in the north-south direction in the tray. Now, a bar magnet is brought close to the needle. What do we see? We see that as soon as the magnet is brought close to the needle gets deflected. Now, magnet is taken off. The needle comes to rest in the north-south direction. Now, we close the key. The current starts flowing through the turns of wire. Observe the needle carefully. It is seen that as soon as the current starts flowing, the needle gets deflected. Now, we open the key. What do we see? The current stops and there is no deflection. What can we conclude from this? When electric current flows through a conductor, it behaves like a magnet. Hence, a magnetic field is developed around it, causing deflection of the needle. Electromagnetic induction. Next, we shall study electromagnetic induction. Michael Faraday, the English scientist, was the first person to prove that a magnet could create current. In order to test this, a coil of insulated copper wire was taken. The coil was closely wound with a diameter of 1 centimeter and with as many turns of wire as possible. Now, the ends of the wire were connected to a galvanometer G. Galvanometer is a device that shows us both the direction and strength of current through deflection of needle. Now, magnet is moved towards the coil. You will see deflection in galvanometer. Now, take north pole of the magnet away from the coil. You will see a deflection in galvanometer, but in the opposite direction. Thus, we can conclude that 1. An electric current flows through the coil so long as the magnet is moving. 2. The direction of the current depends upon the direction of movement of the magnet. That is, the direction of the current as the magnet moves towards the coil is opposite to the direction of the current generated as the magnet moves away. Thus, the current obtained due to the relative motion between the coils and the magnet is called induced current. This phenomenon of the change in a magnetic field and the electric current that it generates is called electromagnetic induction. This is all about electromagnetic induction. Electric motor. Let us now study how magnetic effect is produced in an electric motor. In order to understand, we need to revise the properties of a magnet. 1. Like poles repel each other. 2. Unlike poles attract each other. Okay? Let us study how this concept is used in a horseshoe magnet. We first take a horseshoe magnet and then suspend a coil of at least 25 to 30 turns of insulated copper wire between its 2 poles, so that it rotates freely between the 2 poles. Remove the insulation from the ends of the wire and connect them to a dry cell. The coil is deflected. As we know, dry cell causes the flow of current by applying force. Also, we had seen in the previous section, matchbox and needle, that coil starts behaving like a magnet as soon as the current starts flowing through it. One of its sides develops the north pole and the other the south pole. Now, if north pole of the coil happens to be towards the north pole of the horseshoe magnet, then they will repel each other as like poles repel. the suspended coil will get deflected. So, the coil starts rotating. The electric motor works in a similar manner. It consists of armature, commutator, brushes, axle, field magnet and dry cell or any other cell. The armature is a coil of wire as in previous experiment. The direction of the current flowing through it must be changed after every rotation. Otherwise, when the north pole of the coil comes near the south pole of the magnet, there will be attraction between them and the coil will stop rotating. A commutator is used to change the direction of the current in the coil after every half rotation. This is how an electric motor works, by setting armature in motion by sending an electric current through it.
Now, you are all aware that when current flows through the conductor, it starts working like a magnet. Let us do one more experiment. For this, we take a 40 to 50 centimeter length of insulated copper wire and coil it around an iron nail or screw. Connect its ends to a dry cell and include a key in circuit. Spread some thin iron pins under the nail and then close the key. The moment the key is closed, iron pins are attracted towards the nail. Now, when key is opened, the pins fall off. I guess you all know why does this happen. It does happen because the nail is acting like an electromagnet when current flows through the coil. Advantages: 1. If stronger currents are used in it, the strength of the magnet also goes on increasing. It is because of this property that electromagnets are used in big cranes for moving heavy loads. 2. We get many toys that run on electric cells. The movement in the toys is caused by the electromagnets. Drawback: 1. However, these magnets are not permanent magnets because the magnetism of the electromagnet lasts as long as the current flows.
Electric doorbell. Okay, we now move on to electric doorbell. We are all aware of what an electric doorbell is. We know that when we press the switch, a sound is produced. Let us now see the internal working of this bell. This bell works on the principle of magnetic effect of electric current. Here too, we use a coil of insulated copper wire. Wind it around a cylindrical iron core. The cylindrical core can be made from 7 or 8 discarded iron pull-jerry wires. Also, a key and an electric cell are required. Finally, a flexible iron strip and a metal gong are used to produce sound. That is, when an iron strip strikes the gong, a sound is produced. Now, one end of the wire is connected to one pole of an electric cell. Other end of the wire is connected to screw, which is connected to an iron strip attached with a metal striker. This end of wire, in turn, is connected to a key and then to the cell. The iron strip is placed in front of the magnet wound by copper wire. Now, when we press the switch, the metal strip is already in contact with screw and the circuit gets completed. The electric current starts flowing through the coil and the coil then becomes an electromagnet. This magnet then attracts the flexible iron strip. As a result, the striker hits the gong and a sound is produced. However, in this position, the contact of the strip with the screw breaks and the current stops. The coil loses its magnetism and is no more a magnet. So, the iron strip moves back and again comes in contact with the screw. This causes the current to flow again and the striker again would hit the gong. This make and break arrangement keeps the bell ringing till the switch is pressed. This is how an electric bell works.
Now, let us see electric circuit. So, from all the experiments that we have studied and performed, we have found that an electric circuit requires few basic components. 1. The electric cell. 2. The electric bulb or an electric gadget. 3. Conducting wires. 4. A key that can open and close the circuit. At least these components must be present in a circuit. When the key is closed, the circuit is completed and the current starts flowing through the conducting wires and the bulb lights up. Also, when more than one cell is connected in a circuit, the set of cells is called a battery of cells. These components are represented using certain symbols. 1. Electric cell is represented as 2. Bulb is represented as 3. Key is represented as 4. Wire is represented as.
I think by now you all must be aware of what conductors and insulators are. The conductors are the substances through which electricity can flow. The metals like copper, iron, aluminium, etc. are excellent conductors of electricity. On the other hand, insulators are substances through which electricity cannot flow. Rubber, wool, wood, clothes are examples of insulators. In order to check this property, connect a conductor-like key in the circuit and close the switch. We see that current is flowing through the conductor. That is, conductor allows current to flow through it. Now move the conductor and place an insulator, like rubber, in the circuit and close the switch. We see that the current does not flow through the insulator.